So for number one, this is an instance where they're using lowercase f and capital F, which drives me crazy. Like there's other letters that you could have used. And they sort of throw all this information at you. And what they're trying to do is confuse you. Don't let them succeed. All right. We're going to ignore all of that and focus on this. This should make you think fundamental theorem of calculus. Do you see f of 3 minus f of 0? If a whole lot of a problem looks like gobbledygook, find one thing in it that makes sense and focus on that. Okay. This should make you think integral. That's where that should land in your brain, okay? Are we there? Okay, so it's going to be integral from 0 to 3. And I wouldn't even worry if it's lowercase f or capital F. It's just integral from 0 to 3 of this thing. They only gave you one graph, so you can't mess it up, okay? So we want this area from 0 to 3. We want all of this. Now, this portion right here from 0 to 1, you can figure that out. That's a rectangle, and how much area is that? That's 2 plus, now, I don't have a formula for this. It's not a triangle or a trapezoid or a semicircle. You know, we can't find that one. So now I'm going to go back and look through all that mess that they told me before, and it's in there somewhere. They can't give you an undoable problem. You have to be able to find it. Do you see how from 1 to 3 is 2.3? So what's our answer? 4.3. D is in delightful. All right. For this one, what is the value of integral from -1 to 4? Okay, that's just all of it. Let's find the area of this. We can do a trapezoid or we can do 2 triangles and a rectangle. What do you want to do? Do a trapezoid. Okay, that's 1/2. Oh, the trapezoid is actually right side up for once. You know how usually they're on their side? Actually right side up. What's the height? 2? And then you add the bases together. So the bottom one is 3, the top one is 1. This is also a trapezoid, but I am going to subtract because it's below sea level. So 1/2, what's the height? 1. And then what are your bases? 2 and 1. Let's just be quiet and let everybody work that out, and we'll make sure we all get the same thing. It's going to be one of these choices off to the side. Then Barracuda. All right. Number 3. You're given f prime, the derivative function shown below. They tell you f of 0 equals 0. What that means is your accumulation starts at 0 and you start with nothing. Okay, right? 0. So you start at 0 and you have nothing. You're like at the beginning of time and you have nothing, which is great because you don't have to worry about it. Okay. Now here's my suggestion when I do a problem like this. You can't find these areas because they're not shapes you can do. I would invent numbers for them because concrete numbers are easier to deal with than, oh, about that much. Okay. So can we agree to call this one 2? Like, can we say that that area is 2? I made that up out of thin air. Okay. Now, but if this one's 2, what do you want to call this one? Thank you. You came with me on that thought journey. Why'd you say 3? Because that's a good idea. It's slightly bigger, but you see how now we have numbers to deal with? Instead of, oh, about that much and then slightly more than that much. Do you understand what I'm saying? All right. And then this one is slightly less than either of those, but -1. There. Now we have numbers to deal with. So f of 0, that's the beginning of time, and we have 0. So that's saying 0 is greater than f of 1. If you accumulate from 0 to 1, you get 2. Is that a true statement? No. Get rid of it. F of 2, if you accumulate from 0 to 2, that's both of these little bumps here. So that's 5 greater than f of 1 from 0 to 1 is just 2. Is that a true statement? Yes. Do you see how numbers are easier to deal with than if I didn't call them something? We would just be going about that much. Like, it's a hard conversation to have, right? F of 1, we would say, is 2. F of 3, okay, that's the whole everything, be 4. Is that true? No. All right, so which one is our answer then? B as in beluga. This is an actual AP question. It's from a really long time ago, but the calculus hasn't changed, believe it or not. So I still use it, even though it's kind of an old problem. Let's slice this up and find all of our areas. Where does our accumulation start? 1. Do you see that right there? 1. So my first shape is this triangle here, 1/2 base times height. I just drew a line at 1 because our accumulation starts at 1, or I don't know if you want to circle that or draw an arrow towards it or something to remind you that we're starting at 1. You seem still confused. Is that? No. Okay. So how much is this area? 6. Good. All right, then we're going to need to slice here. This is a trapezoid. It's on its side. So this is the height. So it's 1/2 the height, and then add the bases together. That's 4 plus 1. So what is that, 2.5? And then this one's going to be 1/2. And so this little triangle is -1/2. It doesn't matter if you put this on A, B, C, or D, but at some point, you will have to link together that G prime equals X. If you do this derivative, you get F of X. That's worth a point. You get a point for that. You have to link them together somewhere in the problem. All right, so compute G of 4 and G of -2. For 4, we're going to accumulate from 1 to 4. So from here to here, what do y'all think? 2.5. The positive 0.5 and the negative 0.5 cancel out. All right, and then G of -2, you're going to go from 1 to -2, -6, because you went backwards. Good job. Cool, we got through that one. Critical points, label them as the location of maximum, minimum, or neither. So our sentence is going to start G of X has, and there's actually only one critical point, has a relative. Now, where's our critical point on here? 3. Location of maximum, minimum, or neither? Maximum, good. G of X has a relative maximum at X equals 3. And you're correct with maximum. What's the because? Because what? G prime changes from, no, you were right. Oh, I didn't even catch that. I just heard the positive to negative and I was like, well, that's correct. Yeah, they won't give it to you with it. Sorry. All right, absolute. How do we do that? Candidates test. Endpoints and critical points. Your endpoints are -2 and, what is that, 4? Critical point is 3. I have good news. We already did 2 of those. They like to do this a lot. Reuse something that you already found in a previous part of the problem. It's one of the very few nice things that they do. What was -2? Because we found that back in part A. Yeah, that's -6, and then 4 is 2.5. Isn't that nice of them? We got to celebrate that they did one nice thing. Okay. And then for 3, so you want to accumulate from 1 to 3. 3, good. From 1 to 3 is 3. Don't forget where your accumulation starts. Now, all they asked for was absolute minimum. So you only have to write absolute minimum. Your absolute minimum is -6 at X equals -2. You can write the maximum too. You can write them both if you want to, but this is the one that they're looking for, that they asked for. And we did justify because the chart is our justification. Inflection points. Got my sticky note. Change in concavity is where the graph we're looking at changes. This is the annoying one, right? Okay. So look up there. X equals what? I think there's, is there 2? Oh, there's only 1. X equals 1 because G prime changes from increasing to decreasing there. You don't have to say or decreasing to increasing because there was only 1 and that's what it did. So that kind of shortened what we had to write. So that was another nice thing that they did. Or the whole thing, they have to give it to you. Yep. But it's a timed test, so you don't want to waste time doing that. Yeah, but they will still give it to you. All right, concave up, or no, sorry. Let me read, not concave up and concave down. Oh, this is interesting. We want both at the same time, increasing and concave down. Watch me point to this. Here's increasing and here's concave down. Do you see how it's those two? First one and the last one. So that means where it's the graph we're looking at is positive, above C, perfect, and decreasing. We want positive and decreasing. So we want above the x-axis, but decreasing. That would be from where to where? Perfect. 1 to 3, because G prime is positive and decreasing. Are you guys hanging in there? Wait, I was hoping to do 5, 6, and 7. These go kind of quick because you're all listening to me and it's not that bad. There are 250 M&Ms in a bowl. This is what we call an initial condition. That's what you start with. Initial condition. If you're a physics person, it's kind of like initial position. Not to be confused with initial velocity, that's different, but do you get what initial means? Like, it's how much you started out with. All right, there's 250 M&Ms in a bowl at time 0. Oh, go ahead. I think I have some, though. No. Okay. The rate, so that is a derivative, rate at which they are being devoured. And this is in M&Ms per minute. Do you see how it's per something else? Slope, derivative. Good job. Do you get that? Derivative. Okay, it's E for eaten. They are being eaten, devoured. How many M&Ms are in the bowl at time 3? How many did we start with? All right, 250. Are we adding M&Ms or subtracting them? Subtracting. And then you want to accumulate eaten M&Ms from when to when? Do you see how it's easier when it's a story because it makes sense? Okay. And then what goes in there is E of t dt. Hey, Miss Cole, what if I want to write negative t squared plus 12t? The exam is timed, and if you do a copy error, it's wrong, right? E of t. Okay. I mean, I want you to do well. Tell you. All right. And then you get to use a calculator. So everybody, you get a calculator a lot for this unit. All right. So can you all watch? I'm going to type 250 minus. The way you get an integral, there's 2 ways. The easiest way is INT. If you type INT, it will appear. There's another way you can do it in this menu. I'll be honest, I don't really know where it is and you'd have to search for it. So INT, are we on board? All right. 0 to 3. You know what? I'm not actually sure it'll work with T. Let's see. If it doesn't, I'll change them to X's. Whoops, not 12. Negative. I know. It does have to be X. Yeah. Oh, no, it worked. Cool. Okay, it worked with T. So how many M&Ms are left? 205 M&Ms. Now, does that answer make sense? Yes. What is an answer that would not make sense? Yeah, like more than 250. Like, how would more of them have gotten in there if you were eating them? Or a negative answer. Okay. 205 M&Ms. Find the time at which they are being eaten the fastest. That is a maximum, and those come from critical points. Now, it's actually, this is weird how this is worded. It's actually a rate of a rate because it's being eaten the fastest. Do you see what I'm saying? This is the point in time when everyone's like, nom, nom, nom. Okay. So you're going to, how do you get a critical point? I was about ready to say it, but I'll ask you. Critical point. Good. So we're going to find E prime and set it equal to 0. So what is your derivative of this guy? Negative 2t plus 12 equals 0. Can we all just be quiet and let everybody solve that? I got 6 minutes. So at 6 minutes is when everybody at the party is like scarfing down. Okay?
Okay, never mind.
For sure?
I think I get it. So like this is the so people are accelerating their image.
Yes. 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 Good job.
Okay.
Isn't it funny?
Yeah.
Math word problems are funny.
Slowest, would it be a minimum?
Yeah, but they're not going to do that. It's going to work out. Okay. Set up. Oh, I love these. Set up, but don't evaluate the time at which the bowl would be empty. It's going to be really similar to what we did in the first one. How many M&Ms did we start with? All right. So 250 minus, because we're eating M&Ms. Just instead of integral 0 to 3, we're going to make it 0 to x because we don't know the time when the bowl is empty. That's E of t dt. And what would you set that whole thing equal to if you want the bowl to be empty? 0. You don't have to work it out. They just said set it up. Set up, but do not evaluate is like my favorite set of instructions. That's it. People are arriving and leaving a party. I'm going to stand up because this is so important. Every single year, there is one of these on the AP exam as well. And I reference this party problem. You remember how often I bring up Alice went for a walk about rates and slopes and stuff? I bring up this party problem all the time. This is what we call rate in, rate out. One year, it was bananas. There were bananas on a shelf, and employees were restocking the bananas, and then customers were buying them. One year, it was fish. We're stocking the pond with fish, and then people are fishing. Snowing. It's snowing, but we're also shoveling. There's water in a boat. The boat is leaking, but we're also bailing it out. Are you coming with me on this? It will be on there. Okay? Think of the party. I'm going to bring up this problem a lot. The rate, what does that mean? Slope, derivative, in people per hour. Do you see how it's something per something else? It's a rate. A is arriving. This is your rate in. L is leaving. That's your rate out. What do you notice about the rate out? It's constant. People are leaving at a constant rate. Maybe it's not a fun party. I don't know. And it doesn't say how many people we started with. So we're going to assume the initial condition is 0. They didn't say, so we'll assume it starts with no one. Okay. At what time is the party the most crowded? That means maximum. And that comes from critical point. Now, this one is a little different than the M&M eating one. That one said being eaten the fastest. So it was like a rate of a rate. We just want the maximum number of peeps, okay, at the party. So these are already rates. You're going to subtract them. It is rate in minus rate out. Rate in minus rate out equals 0. Hold on, let me finish this thought real quick. The other thing I usually tell people to do on the AP exam, because this will be on there. Do you see how if you added over the 5, you would have the rate in equals the rate out? If you aren't sure what to do and you've entirely lost your mind, set the 2 rates equal. You'll get a point for that. Okay? I totally lost your mind, set them equal. They'll give you something. Are you sure? Did that answer?
I just thought about this. I was thinking, why would it use independent stuff that we don't have?
Yeah, there's no function. Like, yeah, you don't have that. Yeah, good call. And I realized I did a copy error there. Did you see how I fixed it? Okay. So we're going to go to our calculator. Everybody just watch. In the first one, and I am going to type X for this one, 40e to the power negative X. And the other one, I'm going to type 5. Do you see how I did that? All right. Now I want where they intersect. Oh, you know what? I forgot. When it's a constant, you have to put y equals 5 or it won't show up. Okay. And then there's your answer. You guys are so lucky. You get to just click on that point. Do you know how hard that is with the TI calculators and the mess of buttons you have to push? You are so lucky. Okay, there it is. 2.079. Hours. And then wasn't there a follow-up question for this one? They asked something else as well. How many people are there? We're going to assume we started with 0 because they didn't say. And we just need to accumulate people from when to when. So 2.079, and it is your rate in minus your rate out. It is always rate in minus rate out. Now I am going to do like one kind of fancy sort of thing in the calculator that you're going to have to pay attention to, so everybody watch. Oh crud. Actually, hold on a second. All right, so for right now, I'm just gonna type int 0 to, what was it, 2.079. That needs to be a copy and pasted thing, but I'm gonna look that up and get back to you. All right, rate in. Oops. Minus rate out dt. We're not gonna decimal point a person. So let's go ahead and say 25 people. So at time about 2 hours is when you have the most people there and it's 25 people. Cool? Yeah, equals one. All right, set up, but we're not going to evaluate the time that x when everyone is gone. I want you guys to try because we did this before. Integral when to when? 0 to x of all that stuff. Rate in minus rate out. And then what? Yeah. You don't got to go home, but you can't stay here. All right, and then the last one here, what is the net rate? Net just means rate in minus rate out, at which people are arriving at time 4. These equations are your rates, so you don't have to do a derivative and you don't have to do an integral. All you have to do is plug in 4. So at time 4, we've got 40e to the negative 4th, that's rate in, minus 5, which is your rate out. We can decimal point this one, because it's not an actual number of people, it's a rate of people per hour. So we can decimal point this one. So that's the rate in. So 0.7 of a person is arriving. So negative 4.267. Yes, thank you. I was about ready to bring that up. It means more people, sorry, the rate at which people are leaving is greater than the rate at which people are arriving. So what does that mean is happening about the party? It's it means the number of people is decreasing. It sucks. But yeah, the number of people is decreasing, okay? Because the way they word that on the AP exam is usually, is the number of people increasing or decreasing? And you find this and you would go decreasing because negative. It sucks. That was good though, I like that. Okay, we're gonna do one more. Because we got time. Got plenty of time. This is going really well. All right, I love this problem. This is like one of my favorite ones. A gopher is starting where? He is underground because he's a gopher. So his initial condition is not 10. It's actually negative. Perfect. All right. Right below a tree. At time 0, when our story begins, a monkey is 10 feet above. So his initial condition is 10, positive 10, above the surface of the ground in the tree. They start moving towards each other that's going to be important later. So hold on to that. The speed, which means rate, slope at which they are moving are G is for gopher, M is for monkey, and they are both in feet per second, something per something else. It's a rate, all right? Find the positions of the 2 animals at time 3. Let's do the gopher first. Where does Mr. Gopher start? All right, negative 10. He is moving up. So plus how much he accumulates, which will be from when to when? 0 to 3. G of t dt. I'll go slam that in the calculator, but hold on a second. Let's set up the monkey one. Where does the monkey start? Positive 10, but he's moving down. So we're going to subtract integral 0 to 3 m of t dt. Isn't that fun? It's fun. It's fun, guys. All right. I want you guys to watch and make sure I don't type anything wrong, because I am liable to do that. All right, what's g of t? E to the power negative 4t plus t dt. And then monkey. All right, what was that one? T plus 4 divided by, was it 5? Cool. Gopher is at negative 5.250 feet. Monkey is at 6.7 feet. So let's stop and analyze real quick. What's going on with the gopher? Yeah, he's burrowing out. He's doing pretty good. And the monkey came down, but just like a little bit. Cool.
So what is that number?
So that means the gopher is still about 5 feet underground.
Where?
That's where they are. We found their location. Good question. When, so this is the time, are the two animals traveling at the same rate? What would I do with those two equations? Perfect. So we're going to take G of T and set it equal to M of T. Always write the setup. Usually you get a point for that. So even if you lose your mind and you see same, set them equal. And let's see what we got here. I'm going to actually leave those there. All right, what was gopher? E to the power. Negative, I am going to have to type X this time or the graph won't show up. Plus X. And then the other one is X plus 4 over 5. Thank you. All right, I'm going to zoom in on that. There's two intersections. Do you see that? Which one do we want? Read the problem. The first one. So I'm going to click on that. Love it. Time is 0.075 seconds. And there was a follow-up question, which is what? Well, how fast are they going? 0.815. What per what? Job. Part C, you're going to have to remember what I told you was important. When are the animals closest to each other? Well, it says they move towards each other for how long? So when are they closest to each other? 5 seconds. What they're doing is they're ending the story at 5 seconds. Your window is from 0 to 5 and that's it. What they do after that is their business. We're not concerned with that, okay? Now it says how close are they? I'm not going to rewrite the whole thing, but we're going to repeat exactly what we did in part A, but I'm going to change these 3s to 5s. Now that's the reason I left it in the calculator. So can you all just watch? I'm going to change this 3 to a 5. That's where the gopher is. And I'm going to change this 3 to a 5. Now hold on, we're going to talk about it. The gopher is at 2.749. What does that mean? Not only is he above ground, he started climbing the tree. And the monkey is at 3.5. Okay, so that's not the question though. The question is what? So what do I need to do with those to figure out how close? Good. So 3.5 minus, and again, I should be copying and pasting this number, but I'm not sure how to do that. So I'm going to get back to you on that. I'll just put a whole mess of 9s. There you go. 0.750. So they are 0.750 feet apart. What do you think is going to happen? They're pretty close. Who's going to win? Yeah, no, I feel like that gopher is pretty intense. He burrowed 10 feet out of the ground and then climbed the tree.
If he's tired though.